This is lesson 2 of module number 4, vectors. Here we are looking at the graphical addition of vectors. We've defined a vector as a physical quantity with a magnitude and a direction, and we can describe a vector graphically in terms of an arrow, where the length of the arrow represents the magnitude of the vector quantity and the orientation of the vector represents the direction of that vector quantity. When we add vectors together, we have to account for both the amount, the magnitude, and the direction. And the way that we can do that is using the tip-to-tail method. Obviously, you can only add vectors of the same type and the same units. You can add multiple force vectors, but you couldn't add a force vector and a velocity vector. That doesn't make any sense. If you were adding displacement vectors, you could do that, but you couldn't add a displacement in meters to a displacement in feet. That wouldn't make sense either. You'd have to do some conversions. The resultant is the sum that you get when you add together several vectors. This resultant is itself a vector. Let's suppose that we want to add several vectors together. Here we have 3, for example, but this could be 3 or 30 or 300. You have the same output. This is the resultant. This is the sum. This is a capital sigma for the sum of all those vectors. And this is going to be vector f1 plus f2 plus f3 and so forth. So if we want to add these vectors together using the tip-to-tail method, what we have to do is we start with our first vector. We said that vectors are, in lesson 1, we said that vectors are not limited by location, so we can pick them up and move them around however we want. We'll take vector f1, and we'll just start there. And the idea is we're going to attach the next vector, the tail of the next vector, to the tip of the previous vector. So I have vector f1 here. And when I have vector 2, I'm going to tack vector 2, f2, on the end of f1 with the tail of f2 being connected to the tip of f1. Then I take the next vector here, f3. I'm going to take the tail of f3 and tack it onto the tip of f2, and so forth. And so I start where f1 starts. Where f1 starts here, I'm going to start there. Wherever my last vector f3 ends, that's where our summation is going to end. And then our vector sum points from the starting point to the ending point. From the starting point here to the ending point, from that starting point, from the first vector to the ending point, the tip of the final vector. Here we showed 3 different vectors being added together, but this would work for any number of vectors. That said, this is good for an approximation of the resultant. This is a good place to start whenever you have a vector problem because you can approximate or guess what the resultant is going to look like, and then when you do your calculations, you can confirm that your final answer makes sense based on the magnitude and orientation of that resultant vector. You typically don't want to trust your summation here, just because, number one, to really get a good addition of these vectors, you'd have to use some drafting equipment, which can be tedious, can be a lot of work. And anytime you are doing a drawing like that by hand, there is human error involved. You're adding lines that have a finite thickness and so forth, and so whenever you are trying to take measurements, there's always going to be a little bit of error, and so we're going to generally trust our analytical results. But again, this is a good approximation that gives us a understanding of what the final answer is. There are various formal rules of vector addition. They basically follow the same rules as algebraic addition. So for example, there is a commutative property, 1 plus 2 plus 3, or 3 plus 1 plus 2, doesn't matter. You get the same answer if you add in different orders, and the same thing with vectors is true as well. We have the same 3 vectors, f1, f2, and f3. If you add them in different orders, like we have here, the tip-to-tail method looks a little bit different, but notice that your resultant vectors are all identical to one another. They all point along parallel lines. They all have the same magnitude, and thus they are all equivalent vectors to one another. So it didn't matter what order we did the vector addition. We got the same answer. That is the commutative property. There's also an associative property, which means we can combine these vectors in any grouping. So we could add the first 2 vectors together and find a resultant of those first 2 vectors, and then we could take that resultant plus the next vector to give us the overall vector. We're going to make use of this associative property later on when we get to vector components. there's a special case of the tip-to-tail method, a special case when you're adding only two vectors together. When you have only two vectors, let's say A and B, and you want to add A and B together, what you do is you use the parallelogram method. You sketch parallel lines, lines that are parallel to each vector, through the tip of the other vector to create a parallelogram. So I've got vectors A and B. I draw one line here that is parallel to A but passes through the tip of B. I draw another line here that's parallel to B but passes through the tip of A, and notice that this creates a parallelogram, hence the name of the method. Another common mistake is folks like to just connect the two vectors that they have, but if vector A is pointing up and to the right, and vector B is pointing down and to the right, the resultant has to be mostly to the right. It's getting that contribution from both vectors. So you don't go across this way, you go across that way. Make sure that you're going from where your vectors begin to the far side of the parallelogram. And basically what this method is doing is A plus B gives us a resultant, or B plus A gives us the same resultant, but it's easy to sketch a parallelogram. You can also subtract a vector from another. When you are subtracting a vector, what you'll do is simply add a negative vector. We know how to add a vector using the tip-to-tail method. If you want to subtract two vectors, what you'll do is you would add a negative b instead of subtracting a vector a. So, for example, here I have vector a and vector b. I would take vector b and negate it. I would go the opposite direction. Same magnitude in the opposite direction, that is reversing vector b. Then what I'll do is I can pick up vector b and move it over here. And here is my vector negative b. And a plus a negative b is this vector here. This is a minus b.